Chemists categorize the many different carbon substances by their molecular structures. The most simple are hydrocarbons, molecules that only contain carbon and hydrogen. Most of the Earth's hydrocarbons exist in deposits of natural gas and petroleum deep in the Earth's surface. We use them for a wide variety of purposes, such as gasoline for running our cars, heating homes, and producing electricity. Both natural gas and petroleum are formed from the remains of marine organisms that were trapped and compressed deep in the earth. That is why hydrocarbons are called fossil fuels. There are thousands of hydrocarbons. This is a molecule of methane, the simplest of the hydrocarbons. It is a highly flammable gas that is given off whenever organic material decomposes. That is why methane gas is such a problem around landfill sites. The chemical formula of methane is CH4, but this orbital diagram demonstrates how the molecule is structured. Carbon's 4 valence electrons rearrange themselves into 4 identical hybrid orbital shapes, keeping as far apart as possible. When the 4 hydrogen atoms combine with the carbon atom, the resulting molecule satisfies the octet rule because the outer shell is now full. Methane is part of the alkane family of hydrocarbons, like the one shown here, and a number of others. All alkanes contain only single bonds between the carbon atoms. They are often called saturated hydrocarbons, suggesting that the carbon skeletons are filled to capacity with hydrogen atoms. There can also be branched alkanes, such as this. But the important thing is that the carbons are always linked with a single bond. Diagrams such as this are useful ways of understanding molecular structures, but it is important to remember that these molecules are not flat, like a drawing on a piece of paper. They are three-dimensional, and like all molecules, are in constant motion. The general formula for alkanes is CnH2n plus 2, N being the number of carbon atoms. It is easy to figure out the number of hydrogen atoms in the molecule if the number of carbon atoms is known. Butane, for example, has 4 carbon atoms. N equals 4. We get the number of hydrogen atoms by multiplying 2 times 4 and adding 2, 10. Carbon's versatility allows it to form chains of atoms, but it also can form rings. When they have only single bonds, they are called cycloalkanes, but they have a different formula because they have 2 fewer hydrogen atoms. Its general formula is CnH2n. Saturated hydrocarbons are filled to capacity with hydrogen atoms. Unsaturated hydrocarbons are not filled to capacity. They contain a double or triple bond between carbon atoms. Apples contain ethene gas, which helps them ripen. This is the molecular structure of ethene. Note that there is a double bond between the 2 carbon atoms. Ethene is an example of an alkene. All alkenes have a double bond between 1 pair of carbon atoms, and all of them have a name with a suffix of -ene. The general formula for alkenes is CnH2n. There are also hydrocarbons with 1 triple bond. These are members of the alkyne family, and all of them have a name with a suffix of -ine. The general formula for alkynes is CnH2n minus 2. The naming of hydrocarbons has been designed to specify the chemical structures of the substances. These are the prefixes of the names, which tells us the number of carbon atoms in the molecule. The suffix indicates the type of bond. Methane is a good example. Meth means the molecule has 1 carbon atom, and ane stipulates it has only single bonds. Here are some other examples. The root of the name of the compound specifies how many carbon atoms there are, and the suffix indicates the type of bonds between two of the carbon atoms. Overwhelmed with all of these names? Don't despair. The thing to understand is the pattern of the relationships. As you work with them, the names will become familiar.